Okay, hi folks, this is Mike DeAntonio. I'm actually your amateur weather forecaster. We're going to be talking about how to become an amateur weather forecaster. I have with me David Dubois, who is the climatologist for the entire state of New Mexico. Dave here takes care of all the weather instruments, all the quality control weather instruments in New Mexico, him and his team, of which I'm a part, and which there's a student here, Natalie, who's also a part of this group. And so I'm going to hand the microphone over to Dave, and we're going to let him tell us about one of these weather instruments and how they work.
All right, thanks for that introduction, Mike. As you said, I'm the state climatologist, and we're actually out on site right now in Las Cruces at one of our weather stations. And we're standing here on the NMSU campus, and we've got a station here. So this is the tripod. You can see this piece of metal. This is the tripod that holds all the instruments, the sensors. And so what I'm going to do is go through and describe how we measure weather and show you some of the sensors that we have here. So the first thing we have here is the data logger. This is actually a computer. Inside here, you probably can't see it because you're on the other side of the, but maybe if we can bring the camera a little closer on this side. Yeah. Well, anyway, so this is basically it's just like a regular computer. We'll need to aim it. Yeah, there you go. And so there's inside here. It's all solar powered. So we don't have anything plugged into the power. So we generate solar power, and then we have a little battery right here. So you can see a little battery, and we charge that up, and it powers the weather station. And then inside there's a little computer called a data logger. And basically what that does, I think Dr. Mike here can show you. You probably can see it here on your screen. And so this is the data logger. It's basically like a desktop computer, but it doesn't have a monitor or a keyboard or a mouse. All it does is collect signals. There's wires here that collect the voltages and things like that from all the sensors. And so it's sort of a dumb computer. So think of it as all it does is collect the sensors, and then we've got it so it sends it down, and then we have it connected to the internet. So we have it streaming, the data coming from this weather station streams directly to the internet. And so we can actually go, and maybe a little later after this, we can go on the website and show the data that comes out of here. So what we have is data that comes out every 5 minutes. So the sensors actually continuously collect data, and that's how they work. And we'll show you some of the sensors, but inside this computer, what it does is averages it. It averages it every second, and then it comes up with a minute average and a 5-minute average. And so that 5-minute average is what we send to the internet, so you can look at what the weather is. So we measure temperature, relative humidity, we measure solar radiation, we measure wind speed, wind direction, and we also measure when it rains. We have a rain gauge that measures the precipitation, so how many inches of rainfall. So right now in Las Cruces, I don't know where you are, but it's really dry here. It's nice and warm. It's around 70-some degrees, and there's no chance of precipitation here, but maybe where you are, there is. And so we use these little sensors called rain gauges, and we've got several of them here at our weather station. Maybe we'll have time, we can show you some other ones. But we'll start off with what's here in this weather station. So I'm going to close that box. I'm going to lock it up for here. All right, so let's start off with the rain gauge. Maybe you want to tilt it up. Yeah, I think you guys can see it. Can you see it? Maybe go a little further up. Yeah, basically this guy right there, that white cylinder up there, is a rain gauge. And how it works, you can't see the insides because it's live. Yeah, we can look at that one too. What it does inside, it's called a tipping bucket. And the reason why it's called a tipping bucket is rain falls on a little paddle. And every time the rainfall fills the paddle, it's 1/100th of an inch. So that's 0.01 inches. And so it continuously fills and empties that little paddle. And then when it rains, and then remember we looked at the computer, it records the number of times that paddle tips. That's why it's called a tipping bucket, because it's just like a bucket. it empties and fills, empties and fills, and then it tips every time it rains. So that's how we measure rain. Is it's a little mechanical thing, and then it transmits the number of tips into our little computer here, and then we continuously measure that every second, and then we compute 5 minute totals of rainfall. So when we do when you look at the weather report, sometimes it'll give you the 24-hour average. So we average all those 5 minute intervals, and then we come up with a 24-hour total. So next thing we want to do, let's see what we want to do. We can kind of go over here. Let's do the temperature and relative humidity. And I'm pointing to this guy right over here, and I think you guys can probably see that. So what we're doing is we're angling our camera so you can get a better view of it. And give us a second here while we maneuver, and give Dr. Mike some time to tilt the camera so you all can see the temperature gauge. All right. So let me move over here so I can sort of tell you what's going on. There's a lot of things to trip on here. So anyway, this guy right here this measures temperature and relative humidity. So basically, it looks a little weird because it has this thing that looks like little plates that are glued together. So what that does, it basically shelters the sensor. The sensor is really sensitive. And inside here, there's a wire that comes out. That's where the sensor is. It's about a couple inches above this little black piece here. And what it does, it protects, this white thing protects the sensor from the sun. It protects it from the rain, hail, snow, anything that comes down, or even birds. We got some birds come down here and want to sit on it and kind of look around. So we have this to protect the sensor. And so, and then the way it's designed is these are just like plates, and then there's a hole drilled in the middle, and so air can go inside in between these plates, and then we can expose the sensor to the air. So there's a little sensor inside that measures both temperature and relative humidity. And so with relative humidity, remember, is the way we measure moisture, and we measure it in units of percent. So if it's 0%, that means it's really extremely dry. There's no moisture in the air. And if it's 100% relative humidity, that means it's saturated. So it's like fog. You probably have been into a fog or a cloud. If you go to the mountains, you can drive into a cloud bank, and now the relative humidity there would be right around 100%. We rarely get 100% here in the desert. Even when it does rain, we don't even get 100% because it's not saturated right where we are. It's saturated in the clouds, but not when it's falling. It's just sometimes we get relative humidities of 60, 70, or even 80% while it's raining. So what it does, it tells us, it not only if we see 100% or even something like 90, it tells us there's something going on. There's a weather event on here, and then we look at the temperature. When we see the temperature dip, especially during the middle of the day, we say, oh, there must be a rain event, and then we said that should give us a clue to look at our rain gauge and to see how is it raining and what's going on. And then another sensor we'll look at in just a minute is that tells us the speed of the winds, and that's the next sensor we're going to go. So we'll get Dr. Mike to maneuver our little camera here. So give us a minute to do that. And so while we're setting that up, we can talk about think about where you get your weather. Do you get it from the TV, or do you get it from the radio or the internet? And so it's always good to know where you get your weather information. And when we're done with the recording here, we'll show you some really good places on the internet to get the latest weather. And after showing you where we can get this one. Okay, so I think Dr. Mike has got the camera all set up. He's done a great job with this, so to give him some applause here for being a really good cameraman. And so this thingamajig up top here that's rotating, that's our wind speed indicator. And so that the thing that's turning, that's called an anemometer. And it's anemometer, just like Anna, like a girl's name, and your mom, meter, anemometer. And so one of those tongue twister names that's really hard to say. And so anemometer measures the speed of the wind. So it's wind speed, and our units of speed are either in miles per hour or meters per second. We usually use both of those depending on who we're giving the information to. And then there's a thing that kind of on the back of it has a piece of metal connected like a wire to it. That's called a wind vane. And wind vanes are used to tell the direction of the wind. So and there's a little thing at the end, like a little missile front. That's the weight, the counterweight. And how it's the way it's designed is when the wind blows.
Okay, so we do have a question, Dave.
Yeah, okay. I think we have a question, so we'll take a question. So
the question is, how many of these weather stations are actually deployed across New Mexico?
Oh, that's a really good question. So the question was, how many weather stations are there deployed across New Mexico? And so we have our network's called ZIA-MET, just like our ZIA symbol, ZIA-MET, MET meaning meteorology. And we have 26 stations across New Mexico, all the way across, all the way from San Juan County, the Union County, all the way down to Carlsbad and Hidalgo County. And so that's our stations. And there's other networks out there that are at airports. And so if you have an airport, so if you're in Albuquerque, the Sunport has a station. If you're in Las Cruces, we got a station on the West Mesa. So most airports here in New Mexico have weather stations. And then, so if you go to like weather.com or weather.gov, that most likely you'll probably get the airport weather. So that's where most of your data comes from for weather, your winds, temperatures. There's a bunch of other weather stations out there. There's some on top of mountaintops. They're called snow telemetry. Those measure snow accumulations, and those we use to measure how much snowpack there is in the mountains. There's some others in the wilderness weather stations. They're called RAWs. They're for fire weather. And there's a lot of them out there, and there's other ones out there that are private stations. So like you and me, if we go out and buy a station, you can install it, and then it will measure the weather right in your backyard or front yard, and so you could put that data on the internet. So those are all available and free of charge, and you can go online and get the weather. So yeah. All right, so let's go back. I hope that answers your question. That was a great question, and thank you for that question. So we'll go back to our wind measurement here. So that thing that turns, remember, is the anemometer, and then the other part of it that has a long stem and then a flag at the end, that's called a wind vane. That measures the wind direction. And so that the wind vane points toward the direction that the wind is coming from. So if right now, you probably can't tell where we are, but right now the wind is kind of moving around. So we call that variable wind. So if the wind starts to kick up, it'll mainly stay in one direction. So when it kind of rotates and all kind of squirrely back and forth, that's a variable wind direction. It's mainly coming from the southwest right now. And so that's kind of our predominant winds here, especially in the fall and spring. We mostly have winds from the west and southwest. When we have the summer monsoon, we get a lot of winds from the south. And that's one way to tell what kind of weather system we're having is by looking at the direction of the wind, by just looking at the wind vanes, especially if it's sited in an area where the winds are blowing and it's representative of the general area. Okay, so we've got that. And one other thing that we have is the solar radiation sense. I don't know if you're looking straight at the sun. So I wonder if we want to put this tripod on the other sides so that we're not staring at the sun. You definitely don't want to stare at the sun, but the camera can do it because it's just a camera. But Dr. Mike is moving our setup right around here, and maybe Natalie can move the computer. There we go. We got a good little team here going, making good measurements of kind of helping you understand how we collect weather data. All right. So I think, let's see, Dr. Mike is angling the camera. Let's see if we can, and Natalie is
tend to focus,
making sure we have some shade here. So I might have to angle it up a bit here. Maybe up by like that.
It's not focused either.
It's not a focus?
Now it's focused. Now it's focused.
Yeah, so basically what we're going to show you next is it measures the solar radiation.
You have to point to it.
Oh, yeah.
It's really hard for them.
Yeah, so this thing up here, you're seeing the bottom of the solar radiation sensor here. And it's just a little square that's attached to our tripod. And the reason why we put it up high, so it doesn't get a lot of dust, because the closer the sensor is to the ground, the dirtier it's going to get. So if you ever put your laundry out on the clothesline, you want to make sure your clothesline is high above the ground, because you're going to get splashed during rain and dust. So the reason why we have it up here is to keep it out of the way of all the different weather and dust, because we have a lot of dust. I don't know where you are, but there's a lot of dust in New Mexico, and we want to keep things clean because we want to measure solar radiation. It's basically just like a solar panel. I'm sure you've seen those, but this one is specially calibrated to tell us how much solar radiation is hitting the ground, and we usually measure that in units of watts per meter squared. And watts is just like a light bulb. It measures how much power is coming down, and we measure it over a certain area, so it's a square meter. So it's a little more than a square yard. So it uses the basically same kind of material as a solar panel, and that sensor up there on the top of it measures that, and then it sends a signal down to our little computer down here, and it records that. And so why do we need to measure solar radiation? So a lot of different uses for solar radiation. The solar power industry, that's an obvious one. We want to know how many sunny days. So we want to know how many days is sunny versus cloudy. Another really big use for solar radiation is we want to be able to measure the amount of evaporation. So what's evaporation? So that's when we get water on the ground, it'll basically evaporate. It'll go from liquid to gas form, water vapor. And so why do we need to really know that? Well, we use that to measure how much irrigation, how much water to put on plants. So you may have a grass in your yard, or if you've driven over an agricultural area, they need to know how much water to apply. And so they need to know how much evaporation. And then there's another term that we use, it's called evapotranspiration. So the evapotranspiration is not only the evaporation from the soils, just like when you do left a bowl of water out, but there's transpiration is when the plants themselves are evaporating. They're just like us. We sweat. We're sort of perspiring, but plants transpire. So we use that information. So if you have a field of corn or soybeans or even chilies out there, we need to know how much water to apply. We don't want to underwater. We don't want to overwater. We want to give it just the right amount of water. So we use that solar radiation to help us to measure the amount of evapotranspiration, so that we can use our water resources. We don't want to waste it. We want to be good stewards of the land that we're living in. So we need to use that to estimate. And we have some equations that we plug it into that are that basically give us the evapotranspiration and how much water. And so if you really want to use the scientific method to water your grass, you could actually calculate how much water is needed on a daily basis on any plant, actually. And so we actually use that on some of the irrigation, some of the municipal users. They actually use that information. So they basically, because you have to pay for water. So if you don't want to pay too much. So we use that. So that little sensor up there is real important for us to gauge how much water we use and how much water is needed. So I hope that really kind of gives you a sense of what's going on. So we've got, and then just below that, let me see if I can angle the camera just a little bit here. Just below that, there's a little solar panel. I think you can see that. It's only about a foot by 2 foot or so. It's just a little solar panel. That's what powers our whole weather station. Yeah, and so you can see, so you can see that solar panel up there, and then the wire goes down into the data logger box that we showed, that little computer, and we charge it up. During the day, we charge the battery, and during the night, we use the battery. So that's our whole station. So you can sort of see everything there. I think we got there. We talked about the rain gauge. We talked about the data logger. We talked about the temperature, relative humidity. We talked about the wind speed, wind direction. We talked about solar. And one last thing we'll talk about, which you really can't see it, and it's intentionally, is actually we measure soil temperature, and we measure soil down on the ground here. I can maybe point to it by I'm making Dr. Mike work for his lunch here today because we're moving the tripod around really very quickly. So if you can show, I'm going to film it right here. So there's a wire that comes down, and this wire right here, there's a bunch of spider webs on it. So there's a wire that goes down in the ground. It's like, what's going on there? Is there something plugged in? No, that's actually our soil temperature sensor right here. So right below that, and we measure that all across the state of New Mexico at 10 centimeters. So that's about 4 inches deep, about this far, that far down. And we have a sensor in there that measures the temperature of the soil. And it's like, why on earth, pun intended, why on earth are you measuring soil temperature? Well, a lot of times we use the soil temperature for when do you plant. There are some seeds that require a certain temperature to germinate. And so we don't put the seed in until we're ready to actually do that, especially in the springtime. And a lot of farmers they can kind of feel the soil, or you can use the temperature, but we actually measure the 10 centimeter soil temperature to give that information. So because we work with a lot with the agricultural community, and we have an archive, and we know when the freezing is at 4 inches 10 centimeters, when it thaws out, and when certain times when you can plant things. And so that's a critical measurement there for a lot of people, that the 10 centimeter soil temperature. That measures the same. It's a very similar sensor that we have for the air, but it's right in the soil. So that's our last sensor that we have in our suite of weather stations. Remember, we've got a bunch of those all across New Mexico. We've got stations at all the New Mexico State University campuses. So if you're likely no more than an hour away, or probably less, to some of our weather stations, especially if you're near an airport. So that's probably your closest is an airport. But if you live in Albuquerque, there's a bunch of stations around. We've got a station in Los Lunas. We've got stations all over. If you're outside of Albuquerque, we've got Carrizoso and Grants, and actually in Chaco Canyon, Bandelier. So those are some of the stations. We've got many more of them, but that's where we get our information, and we archive it on our weather station here. Do we want to show that other rain gauge, or what do you think? Probably we're good. So this is basically the same setup we have all over the state. And these are usually they're in a fenced area. We protect them, and then the data gets transmitted different ways. This one has a direct connection. What's it? Okay. And then some of them we have it cell, and some of them go directly to an office. So I think that's about it in terms of the sensors here at New Mexico State. And then I think Dr. Mike's going to say some words and go from there.
Okay, folks, this is Dr. Mike, your amateur weather forecaster. I'm with Dave Dubois. I've actually helped set up some of these weather stations and keep them maintained. That's one of my duties, but you'll find out some of the other things that I do as an amateur weather forecaster in a little while. What we're going to do next is we're actually going to do a launching of a weather balloon, if Dave can get that set up quickly. So give us a few minutes to get that ready, and then we'll turn the camera and we'll actually show you how they launch a weather balloon. And then after that, we're going to take probably maybe a 10 to 15 minute break, and I'm going to actually come back on and give you a presentation of ways in which you can help in weather forecasting here in New Mexico. And I'll give you all my background and some of the things that I do. We have another question. Go ahead.
How often do the stations require maintenance and or calibration?
Okay, so how often do the stations require maintenance or calibration? I think it's on the order of a couple of times a year.
Yeah, we do 4 times a year. Usually.
We do it 4 times per year for each of the weather stations. And we're talking Dave and his crew go all over New Mexico. They even have a weather station up on Magdalena Ridge that I've actually helped set up. So Dave's actually filling the weather balloon. I'm going to go ahead and turn the camera so you guys can see him doing that. So give me a minute to get the camera turned toward him. And this is not quite the way we would fill a weather balloon. He's actually using the helium you buy at the party shop, but we usually use bigger tanks, but we didn't have the time to get one. And that's actually a little smaller than a typical weather balloon, but it gives you some idea of what we would do. It is one of the weather balloons, but a lot of them are about, I'd say they can get up to about 5 times that size. So it gives you an idea. And he's going to go ahead and get this thing filled up, and then he's going to tie it off and put something on it, and then we're going to launch it. So again, once we're done launching it, we'll end this broadcast for now, but then I'll come back in about 15 minutes, and I'm going to actually go through a lot of interesting weather phenomena that occurred here in New Mexico. So let me get back into the camera while they fills. And folks, I'm going to talk to you about some of the interesting weather phenomena I've experienced both in Pennsylvania, where I grew up, and here in New Mexico, including I'm going to actually show you some footage of the beginning of a tornado that actually occurred in Santa Fe a couple of years ago, and then I'm going to show you a photograph that I took of that tornado. So that'll be the final thing that we show you today. We also have many other broadcasts that are already on YouTube. I will give you a list of those and give you the ability to link into those as well. So we'll go ahead and turn back over to Dave here. You can watch him filling the weather balloon. You can see these things get pretty big, and again, I've actually helped launch some of these weather balloons, and the ones I launched were probably anywhere from 3 to 4 times as big as this one. It took a team of about myself and 4 students to do. So it was really difficult. This particular one is very similar in size to the one that they use at the National Weather Service. It might be maybe a time and a half bigger than this. So are there any other questions while we're waiting for Dave to fill the balloon? We kind of use up the time that way. So while we're waiting for questions, I'll just tell you again, the next part of the broadcast is going to be talking about how you can get involved. So if you're interested in helping out with Dave and the National Weather Service and other people, please stay tuned. There's lots of ways, lots of citizen science type projects that I'm going to be talking about, many of which I've been involved in. For instance, I measure rain, and I measure, let's see, what else do I do? I'm actually a spotter for the National Weather Service. I'm an official spotter, which is why I got footage of that tornado. So everybody else was hunkering down. I was out there spotting the tornado. I actually saw it before it came out at the time. So I knew it was coming and was actually giving reports to the National Weather Service in Albuquerque at the time. And I'm going to show you some of the Twitter feed there. Go ahead. So what equipment is attached to a weather balloon? We call it a sonde, S-O-N-D-E. And there's various kinds of sondes. Many of them have a radio attached to them, so we'll call that a radio sonde. And then we attach various weather type devices to it, including the temperature humidity sensor that Dave showed you earlier. We have ways of recording the telemetry using GPS, so we can actually know where the balloon is at a particular time. And one of the projects I was involved in, we actually measured the ozone. So we actually had a special sensor that measures ozone. But typically the weather balloons that are launched by the National Weather Service measure the same things that are measured by the weather stations on the ground. The only exception to that, by the way, would be the wind speed and wind direction. That's kind of, it can be done, but that actually takes a very special instrument because it has to take into account the movement of the balloon and the device, the thing that's attached underneath the balloon. So typically we would actually attach something on that string that it's holding.
Yeah, we'll call this a pilot balloon, basically.
Yeah, this is a pilot balloon. We're just going to see where it goes.
Yeah, you can tell the direction of the wind from this.
Let me get the camera on there. And then I'm going to see if I can follow the balloon with the camera. We'll see how it goes, but it looks like it's going to go off in a direction that's going to make that difficult. We'll see if I can
That's okay.
keep up with it.
We're used to wind.
So here we go, folks. And Natalie would take the phone, but I'm holding the phone and the microphone and the camera at the same time, so I'm not sure how well I can do this. So typically in a real life situation, first of all, we do let the FAA know about this so that the airplane pilots in the area actually know there's a weather balloon in the air so that they don't run into it. And then we usually we try to do it at a very specific time and we count down. So I'm going to make a countdown here. So Dave, are you ready?
I'm ready. Just tell me
when. 5, 4, 3, 2, 1, launch.
Okay,
and I'm trying to keep it on, but I don't think I did a very good job. Let me see if I can turn it around here and see if I can get it into the picture. Doubt it, but if you can check the computer and let me know if I'm even close, Natalie, I'd appreciate it. But I think you can still see the balloon in the picture. Actually, Caitlin, can you see the balloon there?
I think it's in the right direction, but you can't see the balloon.
Okay. Well,
A little higher.
do we retrieve the equipment? Yes, often we do. I know in the particular case that I worked with David, we had these ozone measuring equipment, which is very expensive. So we actually had GPS on the equipment, and we could actually track that equipment through the air and when it landed. And we retrieved how many out of the?
About 7.
About 7 out of the
57.
57 instruments that we launched. We got about 7 of them back. We also typically put a message onto the package that says that this belongs to New Mexico State University, National Weather Service, whoever did the launch, and that you could call that number, and we actually offered a reward if somebody found it. So if you do find one of our devices, please return it. Some of them are very expensive and they're not very useful to you. Also, I should mention that especially with that ozone, it made a very loud buzzing sound. And so we actually put on there that this is not a bomb, that this is actually a weather device. It's just in case somebody got to it before it actually powered down. So I remember chasing some of these balloons through the wilderness, going out into the desert trying to find them. And we were actually able to retrieve 7 of the 57. So go ahead. Okay, so I'm going to put Dave back on and let him answer that question. So again, what was the question? Just remind me. So what is the frequency of use of weather balloons? Are they constantly used or are they only at specific times?
That's a great question. So how often do we launch these balloons? Well, the main launcher of balloons is the National Weather Service, and they do it twice a day. They do a morning launch and then an afternoon launch. And this is done all around the world, actually all over the entire Earth. There's they call it synoptic, meaning all the same time. And so then right around 5 a.m. and 5 p.m. there's a balloon launch, and it goes all the way up to the stratosphere. So they use bigger balloons than we just launched today. What we just launched right now was a 100-gram balloon. They use bigger balloons, and so they actually put sensors on their balloons and to measure the wind speed, wind direction, temperature, relative humidity, pressure. And so that's done twice a day, and that's actually all public data. You can actually, if anybody's interested, you can email me, and I can show you where to get that information. So here in New Mexico, we have launches at the Albuquerque Airport, so right at the National Weather Service, and that's basically on the southwest side of the airport. There's where they launch, and then down in southern New Mexico at Santa Teresa Airport, they do another launch there. And so those are our two places where we do launches in New Mexico. There's the other ones are out of the state, over in Midland, Texas, and Tucson area, in Amarillo. There's so they don't do it very often, and they're not very many places. And there's some other balloons that are more scientific balloons that they do is so Sandia National Labs, and then some of the NASA programs. They actually launch weather balloons. They go all the way up to the stratosphere to measure different things in the stratosphere. So there's the routine balloons, and then there's scientific balloons. And of course, we know during the balloon fiesta, there's another bunch of balloons we see, and those are more of the everyday balloonists. But they actually can take some interesting measurements by where they go. Just like in Albuquerque, they have the Albuquerque box, which basically describes the wind patterns in there. So there's lots of different balloons, and they have all different purposes, and really useful for the atmospheric scientists and the meteorologists. Do we have any other questions?
Any other questions?
Well, do you want to take it over, Dr. Mike?
So let me get back into the camera, folks. So again, we're going to stop here for about 15 minutes, give us time to get back to our home base. And there I'll actually show you some of the results from this particular weather instrument, and then tell you how I got involved and what kinds of things I've done, and then give you some ideas of ways you can get involved as well. So if you want, you can take a break, come back in about 15 minutes. We'll be setting up, and we'll go ahead and continue to broadcast from there. I'm going to ask Caitlin or whoever's in charge there to go ahead and stop the recording at this point, and then we'll start the recording again when we're set up to talk to you some more. Thank you. Hi, everybody. This is Dr. Michael DeAntonio. I'm from New Mexico State University. I just spoke with you along with David Dubois, the climatologist of the state, about the weather instrument we had out there, and we launched a weather balloon. And right now I'm going to talk to you about what it's like being an amateur weather forecaster and working with people like Dave. So it's been a lot of fun working with them. You'll see, in fact, I'm going to tilt my camera down so you can see the logo. I am a part of the New Mexico Climate Center, and I'm a volunteer, basically. Once in a while, they'll pay me for a big project, but that's usually requires more experience and professionalism than most of us have. So we're going to go ahead and start a slideshow here, and I'm going to talk to you a little bit about my background as an amateur weather forecaster. So is it going to show automatically? Can we stop that, Caitlin? Can we get it to hold? There we go. So what I'm going to do is I'm going to take you through a couple of the weather events that I've experienced in my own life. And I'm even going to show you some video and some pictures, etc. And then at the end, I'm going to field any remaining questions that you have. Okay. First slide. So in this slide, I've actually got links to all the programming that we did last year. So last year, we did a lot of programs having to do with weather in the Science Fiesta. All these are on YouTube. There's links here. And I promised that I would give Caitlin this presentation. In fact, she has it right now. So she'll be able to share the presentation with you. You'll be able to click the links. If you click the main link up in the top there, that'll take you to all the sessions that we did in the Science Fiesta last year. And each of the individual ones there, we had several weather forecasters at the television stations do some things with us, some people from the National Weather Service, etc. This year, things kind of got a little out of hand, and we didn't have a chance to put together a full slate of things for you to do. So if you're really interested, check some of those out. I'll even point a few of them out as we go. And let's go to the next slide. So folks, I'm going to talk to you a little bit about my experience with weather. And this is not unusual. I think many of you will have similar stories. In fact, if you want to share a few of them, feel free. First of all, I want to talk to you about my two closest lightning strikes. Now, I want to just let you know that in my early teens, I lived in a place called Altoona, Pennsylvania, which is up in the Appalachian Mountains. It's a city about as big as Las Cruces. It's not a little, shanty out in the wilderness, but it is kind of surrounded by mountains, and we are pretty high up there. And so we actually had a good chance of being hit by lightning if we were out during a lightning storm. I do remember being outside, and I remember that when I saw the lightning, which was just a white flash, it wasn't, I didn't see a bolt. I actually saw white all around me. And then it was what they call a flash bang. In other words, the flash of light occurred and the bang occurred at the same time. I actually was temporarily deaf for a few minutes. It took me a few minutes to get my hearing back. That's how close it was. And when I looked that up online, and I spent some time online looking things up, I actually found that that put me at less than 100 yards away from the lightning. So I was less than a football field away from that particular lightning strike. Now that one was crazy enough, okay? What's even crazier is, again, in my early teens in Altoona, Pennsylvania, we had lots of lightning strikes there. We had my back door open. We had the front door open. It got very hot and muggy there. And it was a nice wind breeze blowing through the house. And there was a channel of wind that went through the house from the back door through the front door. And that channel of wind, when you get wind, fast wind moving in an enclosed space, it creates friction and actually starts taking electrons off of the atoms in the wind. And that means that the wind itself becomes charged, and it's positively charged. And the clouds were negatively charged. And so what was happening, we were watching TV. Fortunately, I was on the other end of the room. The TV was in the front of the room. We were in the back. Me and my sister was with me at the time. And we, again, flash bang, everything got white, big bang, and the television was completely blown out. And that was back when we had tube TVs. So there was kind of like an implosion of the television during that time. So those were times when I was almost killed by lightning. And I'll bet you many of the older folks amongst us who were outdoors a lot could probably tell similar stories where they got that flash bang. So that's kind of like the craziest weather I've ever been in. Again, both times I was very close to being killed. It's not a fun experience, folks. You do not want to go through that if you haven't already. All right, next slide. Again, we were in the mountains of Pennsylvania, and these are not the actual pictures of the particular event, but it's a very similar event. I remember seeing scenes just like this. I don't know if you can make this the actual presentation bigger, Caitlin, but if you can, that would be helpful. But I'll talk you through it. Back in February 1969, I was only 79 years or 7 years old, 79 years. I was 7 years old at the time. And I remember I was about 4'2" at the time. Okay. So I would actually sit there and walk on top of the snow. And the way we did that, the snow would actually, there would be humidity in the place at the time. And so you would get this water form on top of the snow, and then it would ice over and it put a crust on the snow. And those of us who were light, like myself, I was only 7 years old, I think I was less than 100 pounds then. I was a skinny guy. And so I could actually walk on top of the snow if I was very careful and not fall through. Well, I remember walking on top of the snow, and then I sunk in, and it went up to about here on me. So I realized that the snow was very deep, and I went and got a yardstick. We had a yardstick in the house, and I stuck it into the snow. And when I did, the yardstick disappeared. So that's how I know it was more than 36 inches at my house. It was more than 3 feet deep accumulated snow. And so also that same time period, the snow plows would go out. We had some of the best plows in the country in Altoona, Pennsylvania, because we got such heavy snows. And they would start piling up the snow. And over the winter, the piles from the snow plows, if you look down there in the bottom left picture, you can see an example of it. The piles got up to 10 feet high. And it was one of the few times they gave us off school because we had snow all the time. We don't get snow days in Altoona. But it was one of the few days where we actually had a snow day because the cars couldn't see around the piles from the snowplows, and people were having accidents because they couldn't see the other cars coming the other direction.
We have a comment that Aaron says, Altoona. I grew up in Bedford County.
Well, great. Then you've experienced some of this probably, especially if you're as old as I am and we're growing up in the 60s and 70s. That's when we got the really major snowstorms. I've heard they've had a few in the recent years as well. So those of you who are younger in that area would remember that. The most ice I ever saw was in 1973, and that would put me around 11 years old at the time. And the icicles there were about this big around at the top of the roof. And I'm not exaggerating, folks. Very large, like small tree trunk size. And at the bottom, it was about this big around. I had a hard time putting my hands around it as a kid. And those things were weigh like 150 pounds. And it would actually, the icicles were pulling the roofs, pieces of the roofs off of people's houses. So I remember going out there with hot water and pouring it on these things to try and get it to touch the ground and stabilize. So if you grew up in that area at that time, you might remember something similar. But that's how big those icicles would get, folks. It was amazing. And then the coldest weather, and I'm not exaggerating this one, I actually looked it up to be sure that this was actually true. I don't remember exactly which day it was. I didn't have a chance to get the date, but I do see reports of this. It was about minus 30 degrees Fahrenheit outside with a 40-mile-per-hour wind. And when you do the calculations with the humidity the way it was, that's a minus 70 degrees Fahrenheit with wind chill. Folks, 0 degrees Fahrenheit is freezing. Minus 70 is you can go outside and any part of your body that is exposed will get instant frostbite. So they told people don't go outside unless you wear goggles and a scarf and a hat and completely cover up. And I remember my father had to go out and rescue somebody on the street who was stuck in the snow. And he did exactly that and came back in, and he still had a small bit of frostbite on his nose because he didn't cover up well enough. So that was the coldest weather I've ever been in. Is there anybody out there that can beat that? Because I know people from Michigan and Minnesota who might have grown up there might be able to beat those numbers. If you can think of time when it was colder, please let us know. I'll tell people about it here. Okay, we'll move on to the next slide. The hottest weather I remember was June 30th, 1994, and that was here in El Paso, Texas. I remember this vividly because I had to go from White Sands Missile Range. I was actually working there at the time, and I lived in El Paso, and had to drive back to El Paso, but my car wouldn't work because it was too hot. So some guy offered me a ride in the bed of his truck. So I'm out in a truck driving down War Road and onto the highway, I-10, down to El Paso to my home in 114-degree weather, folks. That was hot. I remember when I got inside the house, I immediately just started pouring down sweat. And I took a cold shower and went to bed because I was so sick from the heat stroke that I was facing at the time. So, folks, not a good idea to be out in weather like that, especially if you're going to be working or running or anything like that. If you do go out in hot weather, take it easy, drink lots of fluids. You don't realize you're losing fluids. And I can tell you we hit 109 degrees when we launched some of the weather balloons I told you about earlier. And so I had to keep my crew well hydrated and kept sending them off to restaurants to go get something for us to eat, not because we needed anything to eat, but because they needed to get out of the heat. And if I told them that was the reason, they wouldn't go because they're all too prideful to get out of the heat in this area. Okay, and again, next one. So I wasn't actually in the hurricane. The hurricane actually went to tropical storm status, I believe, somewhere in Northern Virginia. But those of you who are older can remember Hurricane Agnes. And Hurricane Agnes actually passed through my area. We got 15 plus inches in my hometown of rain from the tropical storm. So to give you an idea, the worst we've ever gotten in El Paso is 6 plus inches in a day. That 15 plus inches occurred in 2 days. Okay, so it was really amazing. Lots of flooding going on. Again, we were high in the mountains, so we didn't see the flooding, but Johnstown, Pennsylvania, which was very close by, had a major flood. A lot of people died in that storm. And I heard people say things like, well, we never get hurricanes in Pennsylvania and New York. And that's really not true because Hazel, my father told me the story of Hazel actually went through as a hurricane through Pennsylvania. It was still a hurricane as it entered New York. So you can look up Hazel. You can look up Agnes. Occurred in 1972. I was 10 years old at the time. My father was older. I don't know exactly when Hazel was, but you can look it up and find out when it went through. So Hazel is a hurricane that actually went through Pennsylvania and New York. So I'm going to pause here, see if there's any questions about those things or any comments you want to make. And then, Caitlin, you can move me to the next slide while we're waiting. And I'm not hearing anything. So again, if you guys want to ask questions, you can ask questions at any time, and Caitlin will feed them on to me and I'll answer them. Folks, this was in El Paso, Texas in 2006. This is what my backyard looked like in the worst of that storm. Now, I don't know if you can see it really well. Caitlin, you can see the swimming pool in the lower left there, and you can see the decking. And there's like these little ripples on the decking. Can you see that? I'm waiting to see if Caitlin lets me know you guys can see that okay.
Yeah, we can see it.
Great. Those ripples are water. The pool overflowed. The fence that you see in the background in that picture, that rock wall and that fence, part of the rock wall, the fence was perfectly straight before the storm. At the end of the storm, it was bent outward. And I wish I had good pictures. I don't live there anymore. I would go out and take pictures now. But that fence bent outward. And there was an area, if you look in the picture on the upper right behind the bush on the left, that area actually caved in and went down 100 feet. There's an arroyo 100-foot drop from behind my house. All that dirt went down in there, and that was an area of about, I'd say, 2 yards by 3 yards by 1 yard of dirt went down in there. So what is that? That's 6 square yards of dirt I lost in my yard. That happened while I wasn't there. My wife actually saw that. She called me here in New Mexico State. I was actually teaching at the time and told me to come home because she thought her house was going to fall into the arroyo. And so I got in my car and drove back. And this was in the height of the flood. They had closed the highway. I couldn't take the highway, so I ended up on Route 28, I think it is, down there by the river. And I was driving down there and listening to reports from the weathers, from various radio stations. And they told me that the Rio Grande was about to overflow its banks. And I was like, wow, this doesn't sound good. And there was one point at which I was stopped by a policeman because the road was actually blocked by some dirt. They had a mud flow move over I-28 or Route 28. And so he directed me back up on the highway knowing I was trying to get home to El Paso. So I was the only car on I-10 at the time in that area. And so I drove all the way to El Paso, came off at Red Road. We actually lived in the Franklin Hills area, if you guys know where that's at. And if you could show the next slide, Caitlin. If you see the lower left picture, that's not the same place, but it's exactly the way the road looked as I was trying to get up to my house. I actually drove through water as deep as the one in the lower middle. And the one on the lower right is actually a good example of what that looked like trying to drive through the water on the way home. And in fact, if I'm not mistaken, 2 of those pictures, the lower left one maybe, and lower right one are clickable. And if you would do that, Caitlin, and see if we get the video. If not, it'll take us to the next slide and then it will be video.
Yeah, I'm not sure it's going to let me click on the videos with the streaming program, unfortunately.
Okay. Oh, shucks. That's too bad because the videos are very, very good here, and it will give you a really good sense of how bad it was. But even from the pictures, you can see how bad it was. All these were taken in El Paso in 2006. I think it was June 2006 when that flood occurred. Is there anybody in the audience today that remembers that flood and can tell us a few stories about it? just let us know if you were in it, and we'll give you time to kind of share. You can share through Caitlin, and then I can talk about it here. I can tell you a couple of stories that I do know. Only blocks away from my house, about 5 blocks away from my house, they had a mudslide that put about 3 inches of mud into some brand new homes. Our home was brand new as well. We, like I said, lost part of our yard, but we were fortunate. We actually used swamp cooler pumps to pump out our backyard and keep it from getting too bad. And we actually backwashed our swimming pool, which got enough water out. I was out in the middle of that storm trying to save my neighbors' homes, trying to get sandbags in there and pump water so the water didn't get into their homes. Again, 5 blocks away, a lot of people lost their homes because of the mudslides. And there was actually a case, and I never could find a picture of it, but there was a Blockbuster store where they sold videos that was actually pushed by the water out through their parking lot into the road. The entire store, not parts of the store, the entire store was lifted off its foundation by the water and pushed out into the road. So that's how amazingly bad that water was. And I do know why the water was moving that fast and why we got so much of it. So I'm going to share that with you. I talked with the guys from the National Weather Service and with Dave Dubois and others who were very knowledgeable. And what they told me was that up in the mountains, there's these ravines and valleys, etc., and there's these natural dams that form that are just, places where the dirt has built up over the years, and there's trees, etc., and a large amount of water built behind those dams. And so those dams burst. And that's why we got these big periodic flash floods that occurred through El Paso during that time. So if you were involved in that and had one move through your home, it was actually a dam break that actually caused that. I do know in Juarez that the situation got very bad too, so I feel bad for the folks down there. The Valley of El Paso got hit the hardest. I think Hatch, New Mexico got hit really hard too. So my feelings go out to those folks. I mean, we faced enough damage that I can't imagine what it was like for you. So really bad time for us. If you guys are younger and watching this, you might not remember this. Ask your parents or your grandparents. They'll remember, because that was 15 years ago. So if you're really young, you won't remember it. Some of you teenagers probably faintly remember it. But if you're in college or above, you remember this time if you were living in El Paso. So any comments or things, Caitlin? If not, we'll move to the next slide. Okay. The other thing that most of us will remember, unless you're less than 10 years old, is the freeze in 2011. Now, again, remember, the coldest weather I was ever in was 40 below zero without the wind chill and 70 below zero with the wind chill. What we faced in El Paso was temperatures rose no higher than the upper 10s and actually went below zero for most of the time. And this was on February 2nd and 3rd of 2011. I was in El Paso at the time. My friends in Las Cruces tell me it was fairly much the same here. They were a couple degrees higher. A couple of things occurred that you might not have understood at the time, and I want to explain to you.
We do have a comment.
Go ahead, comment.
Darren says, I experienced Hurricane Agnes and the Johnstown flood of 1977. Your El Paso pictures look very similar.
Yeah. And so, again, the flood here in El Paso was very similar to what they experienced in places like Johnstown. That is true, except for the dam break. The dam break put even more water into there. So, yeah, I appreciate that. Back to the February freeze. Some of you remember this. I'm sure most of you remember this, but you probably don't know why certain things happen. So one of the things that happened, we had these rolling blackouts, remember, where the power would go down. How many, some of you would remember experiencing that. And they tried not to do that in areas that were important, like near hospitals and near, trying to remember, the hospitals was the main one. I think if school was in session, they tried to keep the power there. And what happened was the power grid, where we get the power from, froze over, and some of the transformers froze. And so they weren't able to transform the power from the California grid and send it to us in El Paso and Las Cruces area. And so what they had to do was, with what remaining power they had to ration that. And so those power outages weren't occurring because of some break of a power line. They were actually occurring because the power company, El Paso Electric, was turning off power to certain areas to conserve it for areas where it was really important, such as hospitals. So I remember at least, I think we got it on for about 10 minutes every hour during those 2 days in my home. So we were without power for 50 minutes every hour. And then every once in a while, it would turn back on. And I remember this because we had gas heating and our pilot light would go out because the gas also went to a crawl. You guys might remember that, folks. And I just realized my computer battery is dying, so I'm going to go ahead and plug it as we're talking. I thought I had plugged it in, but I guess it's not working. Let me see if I can find a better power supply. It's not switched on. I just have to find the on switch here. Or it's not plugged in. You know what? We'll make this quick. Okay, so again, what happened there is, again, they experienced the freeze. It froze some of the gas lines. And so they were unable to get more than a trickle of gas out. So they started rationing that. It affected 900 customers in the El Paso area. And we had just barely a trickle coming into our homes. Some of you had no gas at all. And so many of us were without heat. And I remember this vividly because for 10 minutes every hour, I would rush to both of our heaters, light the pilot light because those were electric. And then I would have gas for about 5 minutes, and then they would shut the power down again, and we would lose gas and power both. We also had a water main break occur near our house. So we had no water, no gas, no electricity for 2 days. So that was not a fun experience either. All right, so it kind of gives you an idea, and there you are. Good, we're back. So very sorry, folks. I guess I shouldn't badmouth the El Paso Electric because, actually, it wasn't their fault. I was actually plugged in a place that doesn't have power. I'm using a friend's desk, and he showed me a plug, and it actually doesn't have any power to it, so I had to plug in somewhere else. So we're good now. I'll be on for the rest of the time. Sorry for all these technical difficulties. All right, we can move to the next slide, Caitlin. All right, and many of you have experienced these dust storms, right? You remember those? They are actually called haboobs, Haboobs. That's the technical term for these things. And you'll never hear a weather forecaster on television call it a haboob because it has a bad connotation. But that is actually the technical term, and I'll use it here because it is a technical term. We had a haboob go through Las Cruces on June 24th, and as a spotter for the National Weather Service, one of my jobs is to let them know when a big storm is coming and when there's going to be problems. And that one I got a good picture of. You can see it there. And that thing I put on my Twitter feed and sent to the National Weather Service. And Monica Cortez actually follows me on the Twitter. She's one of our local weather forecasters at the local television station. And she actually showed this picture that day on the television weather forecast. So, folks, if you take good pictures, you can feel free to send it to these folks at these various TV stations. They have many links. You can just go on to the station website and send pictures, and often they'll use them. They are very happy at sitting on the ground, especially since Monica's in El Paso and she still has to report Las Cruces news. She really appreciates us in Las Cruces helping her out that way, any of the weather forecasters there. So this was part of my job as a spotter, but you can actually send stuff to the weather stations and they will, if it's a very severe emergency, they can often get it to the National Weather Service. Go ahead and show the next one. And again, if you want to make them bigger, you can. So this is I told you I would talk to you about some of the citizen science we do. One of them is to be a spotter with the National Weather Service. And in fact, there's one of the links that I gave you earlier will take you to a video that talks more about that. Anybody above 18 years old can be a spotter for the National Weather Service. It takes about 4 hours, 2 sessions of 4 hours to get trained, and then you can be a spotter. What you do is you watch for these storms and you report it to the National Weather Service. And often they're like the Weather Service here for Las Cruces is in Santa Teresa. So they don't know what's happening out here. And so us spotters are the ones that let them know that. The other way you can get involved is a thing called COCORAS. That's community rain and hail and snow. And that is, you can see on the picture there, above the picture, it says an official COCORAS reading. That's how you spell it, with the 2 capital C's, a capital R, and a capital H, and a capital S. Okay, and that you can sign up for. You can actually look that up on the web and sign up for. There is also another presentation that I linked to that you can actually find information on that, or you can contact Dave at the New Mexico Climate Center, and we'll give that address a little later. I think that's, let me see, weather.newmexicostate.edu or weather.nmsu.edu. Okay, if you go there, you'll be able to see the site for the New Mexico Climate Center. They'll have information about COCORAS. They'll also have the weather instrument that we looked at earlier. They'll have the recordings from that. Unfortunately, the way things are set up, we won't be able to show you that. This is the biggest rain event that I measured. And at the time that I took the picture there, it was 1.5 inches. By the time it was all over, and the next morning we reported the morning, you can see I reported the first line in the upper right there. That's my station. And that was on June 11, 2019. At 5:41 a.m., I reported 2.34 inches in my device. So that's a lot of rain for this area. Remember that the El Paso flood, the total was 6 inches. So back on June of 2011, we actually had a very large rain event pass through. This was my home in, I live up on the Picacho Hills area. So it's in that home there. And the best I had done before that was in Las Cruces, again, that same home. And it was only 2.05 inches, and that was in October of 2018. So give you an idea. And so what you do is you buy these devices, or if you promise Dave that you will actually do readings, he might be able to get you a free device, okay? But you have to convince him. And then he will even help you set it up, and you actually make your readings. There's an inner tube. If you look at the picture on the right, there's an inner tube and an outer tube. The inner tube holds up to 1 inch. The outer tube holds under 4 inch up to 4 inches total. Okay, so we can hold 4 inches of rain in these. You must use the device they suggest, or you can't be part of COCORAS. And they expect you to go out and make a measurement every morning, and they call us zero heroes if we actually put in 0 rain. They really want those measurements as well. As a researcher at the university, I can tell you that makes a big difference to me. So if any of you are COCORAS participants, please put in your zeros, okay? And that's one easy way to get involved. Again, I'll see if we can give you Dave Dubois' email address. In fact, if you have that, Caitlin, feel free to give that to everybody who's attending, or even put that with the link for the recording so that people can contact Dave directly about that, because he is our local COCORAS coordinator. All right, next picture. Okay, here we got what's called a Kelvin-Helmholtz instability. And these occur because you get these waves in the atmosphere. The lower left actually occurred on November 7th of 2019. It was only 2 years ago. I was actually driving down the road, pulled the car over. By the way, do not take pictures while you're driving. very dangerous. You pull over and then take the picture. And what it is, you can see it looks like waves in the clouds. And those are called Kelvin-Helmholtz instabilities. And so if you've ever seen one like that, please take a picture of them. They're very rare. And please send them to the National Weather Service or to myself. You can see there, you can get me on Twitter at DeAntonio Mike. Okay? And if you actually follow that, you'll get all my reports to the National Weather Service, plus a lot of very, very good pictures that I take of weather around this area. The other picture is also a Kelvin-Helmholtz instability, but it happened at night during sunset, and you can see it over the Oregon mountains there. This other one is very, very, very rare to get one to show up in a fog bank like that. And this was actually a fog bank that was occurring on the foothills of the Oregon mountains. And in fact, the people at the National Weather Service told me that that's the only time they'd ever seen a fog bank do that. They haven't even seen pictures of that. So it was a very rare event. I was very fortunate to have the presence of mind to take a picture of it and send it in. So I have one of the only pictures of a fog bank doing a Kelvin-Helmholtz instability. Okay, next. So pictures like this, by the way, the National Weather Service likes. The weather stations, if you want to send it to ABC or NBC, the local weather stations, they like pictures like this. Okay, I'm going to ask if anybody knows what this one's called. See if anybody knows what kind of cloud formation this is. Do we have any takers, Caitlin?
We don't have any comments yet, but we do have a little bit of lag on the Facebook.
Okay, that's fine. We'll wait a few minutes, and I'm going to let you guys try to figure that one out. Okay? And there is a link that I'm giving you at the end. Again, you'll get these presentations. I'm assuming you can get this to the participants somehow. And we'll get you the presentation, and at the very top, there's the link there. There's one that talks about clouds, and they actually mention this one there. But you can look around, and if nobody knows by the end of this talk, I will tell you. Okay? So you guys can look it up. All right, so let's move on to the next picture. We'll give everybody an opportunity to show off and see if you can look it up and find out the name of that cloud. So let's go to the next slide. All right, here's what's called a sundog. Now, I want to point out to you, it looks like you're looking at the sun through clouds. That is not the sun. The sun is actually over in the far left. This is actually a rainbow effect that you can sometimes get in what are called cirrus clouds. They're very high atmospheric clouds where you have water crystals that form. And I do know that everybody knows this one, so let's see if somebody wants to answer. What's the shape of a crystal of water? So is it hexagonal, octagonal, or cubical? And while we're waiting for the answer, I'm going to tell you that these crystals form, and they're actually not like snowflakes. They're long, thin crystals of this shape, and they spin in the atmosphere. And as they spin, it actually takes the light, and the light diffracts through it and disperses into a rainbow. And because of the spin, it puts that rainbow about 20 degrees away from the sun. So the sun is about 20 degrees to the left of these sunspots. And these are two different sunspots that I took over the years. You can find even better pictures on the web if you want to go look up sunspots. Sometimes they get bright, but these actually turned out pretty bright, and I took a couple pictures. So nobody's answering my questions. We'll go ahead and move on to the next slide. This is the tallest cloud I've ever seen. As it says here, I actually sent this to the National Weather Service, and in fact, I kept taking pictures of this cloud as it was forming. And later on, I'm going to show you one with what we call butter on top of the pancake. Remember those words. It started out that way and ended up like this. This thing put out a major hailstorm, okay? And I was able to take a picture and give directions to the folks at the National Weather Service. They said that it's one of the tallest clouds they've ever seen as well. And this one actually took 2.
There we go.
Once again, very sorry, folks. We're going to see if we can pause those pictures, go back up to where we were. There we are. And I don't know what's going on with my computer. Again, I'm in an unfamiliar place, so it's kind of having problems with power. So hopefully we can get through the rest of this presentation with no problem. So again, this was the tallest clouds that they had seen in the end of the National Weather Service in El Paso as well. Let's go ahead and go to the next slide. And by the way, in case you didn't hear, the answers that you gave are correct. It is a lenticular cloud that we were looking at. And yes, the ice forms in hexagonal crystals. And here's some good pictures of a double rainbow that I took. I bet you probably got a bunch of double rainbow pictures yourself. And they're very hard to take good pictures of them without filters. This is not filtered with a cell phone. And this is one of the very few areas where we can get good pictures of double rainbows without filtering on a cell phone. So we're very fortunate that we get the right backgrounds and we get the right lighting to get that. So I just thought I'd point that out to everybody. Let's go ahead and do the next slide. This is actually a front. And if you've ever heard them talk about a cold front or a warm front, there are very few times when it's visible to the naked eye. This was one of the few times when it was. And I actually verified that the front was right over my home at the time that I took this picture. And you can see over on the right, there's a lot of clouds, and over on the left, it's fairly clear. And that's because the moisture forms when it's colder, and it's less, or it's more dry where it's warmer. And so you can clearly see the frontal boundary. And it's one of the very few times I've been able to take a picture of an actual weather cold front. And I bet you some of the guys from National Weather Service are going to watch this later and tell me I'm wrong. But I bet you I'm right. And if you guys go back and were able to find that day, you'd find the front was right over my house. Anyway, moving on. This is actually what you can get out of some of these nice cameras. I've actually got a Samsung 8, Galaxy 8, and this thing can take pictures of infrared pictures at night. And so this was actually a report I was able to send to the Weather Service in El Paso, to Monica Cortez and a few of the other folks that were at the television station doing weather. And they all thought it was really cool that we could actually get pictures of rain at night, which is very hard to do. And now with some of these cell phones, we can do that. And if you got one of those cell phones, I can tell you the National Weather Service would really like you to send them pictures at night of the rainstorms. So if you want to send it to here at El Paso, it's at NWS El Paso. You can see it there on the screen. And if you want to send something to David Dubois, it's at NM Climate. Okay, and then you can see Monica Cortez at KTSM and Doppler Dave Spielman. His moniker at the Twitter is there. And if you want to send something in Albuquerque, it's actually pound NMWX is the one that the National Weather Service looks like at there. They also have at NWS Albuquerque, but they don't look at that as often. So we can move on to the next picture. Here is actually one of the guys from the National Weather Service in El Paso, Jason Laney. And he was actually doing the Skywarn training, which is the training for the spotters. And he actually did it at New Mexico State University one year. And if we get enough people interested, and you can contact myself or Dave or even the National Weather Service, tell them you're interested in becoming a spotter. If we get enough people interested, they put on these trainings. And I've been begging them to come back up to Las Cruces and do one, and they think they're ready to do it. So be watching for it. Again, if you do pound Skywarn on your Twitter feed, or if you actually go ahead and follow the National Weather Service in El Paso, NWS El Paso, you will get some indication of when and where those trainings are. Okay, so we can move on. This is one of the things that Jason taught me. Sometimes you get these cloud banks, they form these nice cumulus clouds. If you know what cumulus clouds are, you already know what I'm talking about. If not, you can look them up on the web and see what they look like. And they start to form that anvil shape, and then they kind of disperse. And this is after one's dispersed. But all of a sudden, you get a second cumulus cloud go on top of it. And it looks like butter on a pancake, right? And so what they've asked is if you ever see that, the National Weather Service wants to know, because that tells them that it's broken through what's called a boundary layer. And once it breaks through the boundary layer, a particular boundary layer, they know that there's a good chance of hail, and there's a good chance of things like tornadoes and things like that can form underneath. So it becomes a second level in their emergency forecast. And so you see me report it there. Thunderstorm in the direction of Alamogordo. This was actually right on top of Alamogordo at the time. Seems pretty far out. Looks like butter on top of the pancake. That's how I reported it. I gave a wink and a smile because Jason actually got mad at me because I didn't report it correctly one time. And Jason's one of the ones that sees these. So he actually wrote back to me and said, finally, you got it right, Mike. So if I ever see a little bulb showing up on top of one of these clouds, I report it to the National Weather Service. That's when they start saying things like you'll start getting warnings about flash floods and hail and things like that. So often it's a spotter that sees it first, and then they look on the radar, they verify it, and they say verified by radar. So once in a while, you folks in Alamogordo, you get these reports of possible hail, or the Jornada area, or even anywhere in Las Cruces, or even down in El Paso. I can see as far as El Paso from my home. A lot of those reports are coming from yours truly. I'm actually sending them to the National Weather Service. They're verifying it by radar and putting out notices. And I've actually seen when I put something like this up online to them, within a minute, a new warning comes out. So it's well worth the effort to get trained, and you can actually be helping out in that way too. Move on to the next slide. Sorry. Now this is where things get really interesting. One of the things that Jason taught us was what are wall clouds. And wall clouds are clouds sticking below the basic cloud base. And if you look carefully at the picture, you can see up where the writing is at, there's a cloud base there, and then down at the bottom picture, there's a cloud below it. That is either a shelf cloud or a wall cloud. I'm not going to train you on which is which, okay? That, if you really want to learn it, you have to take the spotter training, because I want the professionals to tell you the difference between a wall and a shelf cloud. This particular one was a wall cloud, and I knew it was a wall cloud, okay? But I didn't report it as a wall cloud because it wasn't quite well formed, and I wanted to be sure it was a wall cloud before I reported it that way. But I let the folks know in Albuquerque that I was facing directly south. I'm an official spotter for the Las Cruces visiting Santa Fe, and I told them the address I was staying at. So they knew where this cloud was. Okay?
I have a question in the chat.
Go ahead.
What are the typical requirements of a weather spotter?
A weather spotter is somebody 18 years or older who's taken the training. Simple as that. So you have to be 18 years or older and take the training, and then you can become an official spotter for the National Weather Service. And again, if you're very interested in that, I'll give you my contact information at the end of this. So if you can't get to anybody else, contact me, and I'll put you in touch with the folks that are putting together those trainings and make sure you get into the next training if you want to do that. Okay? Move on to the next picture. This is the same cloud. Now it's closer. Okay? You can, if you look carefully, you can kind of see right in the middle of the picture, there's a piece coming off of that, and it's forming in the shape of like a horizontal funnel. It's really hard to see in these pictures. I had to lower the contrast or lower the resolution of the pictures for you guys to be able to see this today. But that is eventually going to, and that is actually starting to rotate. Okay. But you see here, I say seeing only slow rotation. So I'm actually letting them know I see rotation in this cloud right here in the middle. And I don't know if you can point to it, Caitlin, and I can tell you where, if you're pointing in the right place. If not, that's fine. But it's right in the middle of the picture there. And that thing is rotating. And I let the National Weather Service know, and I sent this picture. They saw the picture, and I actually made a short video so they could see it was only slowly rotating. So go to the next one. Then the hail hit. So a few minutes later, we got hail. So I just started with hail. You can see it's very tiny pieces. It's out on the veranda where I was staying. I was staying at a bed and breakfast. Okay. So at 5:21 p.m., we started getting hail. Go to the next picture. That further let me know that there was a chance of a tornado. At this point, the National Weather Service was actually starting to put out warnings on tornadoes, because of me and other spotters were seeing these sorts of things. Then only again, a few minutes after that, we started getting quarter-sized hail. And you can see there's a picture of my finger, and I can show you my finger here. And my finger, the tip of my finger is about the size of a quarter. So I was actually able to verify it was quarter size. They do want you, if you send in pictures of hail, to say about how big it is and use money, penny, quarter, dime, or something like a pea or a golf ball, whatever you think is closest to it, and then put something next to it, either a coin or your finger or something, so that they can get a feel for the size. Next picture. Now, at this point, I would love to have the videos. We don't have the videos running. If somebody wants to see the video, they can contact me and maybe I can get you the video. But this part, right underneath the cloud, you can kind of see a dark area there. That dark area was starting to pull stuff up into it. It's called uplift. And that's the technical term. It's an uplift. So I let the Weather Service know now we're starting to see uplift. So we got rotation, we got uplift, we got moisture, and we've got, in the previous pictures, I didn't point it out, but the fact that we have a wall cloud means that we've got, I'm trying to remember the actual technical term for it, but we've got various air currents going in opposite directions. Those things let the Weather Service know that that could possibly lead to a funnel, okay, that there could be a funnel cloud coming out of that. So next picture. That's the funnel that came out of it. I reported it as a funnel cloud. The funnel itself never actually touched the ground, so it is what they call a land spout. However, later on, I talked with some folks and I actually reported it wrong, because as that thing came over the house, it was actually picking up debris around the house. And so it actually was a tornado. It wasn't just a funnel cloud. I wasn't the only one to get pictures that day. If you go on the web, you might find some other pictures of that particular tornado. It actually is a tornado, although officially recorded as a land spout, because several of us said it never touched the ground. Again, I would like to go back and talk to the folks at the National Weather Service in Albuquerque. And next time I go, I'll report this to them and say, look, I do believe that was a tornado. You might want to change the designation. So that was the most exciting event I was ever at. And in fact, if you could see the video, you'd see me taking a video of the funnel coming down. The previous picture, if you go back to that. So if we can go back up one, yeah, that previous picture, that part coming out actually started forming the funnel in the video. You can't see it here because we're not running the video, but you can actually see the funnel start to come out. Okay, and we could see the uplift going, and then it started forming and started rotating. And at that point, you could see me put my camera down and go in the house. And I told everybody in the house, go into the center of the house, get away from the windows. We have a tornado. Okay, and of course, all my family and friends all wanted to go to the windows. And I told them, if you do, you can get killed. Stay here. Wait a few minutes, and I'll show you the funnel later. Yep.
What's the difference between a tornado and a microburst?
Okay, microbursts. I've been in those too, okay? And I don't have pictures of them because you can't get pictures of them very easily. A microburst is where, how do I put it? The bottom drops out of the atmosphere and you suddenly get this great deal of wind that comes straight down, hits the ground, and goes sideways, okay? And so if you've ever been in a microburst, you'll know it. Trust me, the wind is actually very strong. I'll give you what the experience I had was. Sounded like a freight train, sounded like a tornado, okay? Came straight down and it started picking up, like the water in my pool started coming out. It actually picked up, the one I was in actually picked up a grill, a full-size grill, and put it up over one of our rock walls and took out one of the swamp coolers of my neighbor. It actually took it right off his roof. That's how big that one was. And I was indoors when that happened, but my neighbor was outdoors. And he tells me that it actually picked all the water of his pool up out of the pool momentarily and dropped it back down. That's a microburst. A tornado is the funnel cloud like I showed you. That's a whole different process. It actually starts rotating horizontally. And as I told you, I could see the horizontal rotation forming. And then eventually that tilts down. And it starts picking debris and moisture up off the ground, and you start seeing the funnel form. That's a tornado. So a completely different process. Microbursts tend to be bigger as far as area coverage. Tornadoes tend to be pretty small in area coverage. Even the biggest tornadoes that were a mile across, those are F5s, F6, and those are really unusual. Most of them are only maybe 100 meters across. Whereas a microburst can actually hit an entire neighborhood or bigger. And we've had quite a few microbursts in this area. So if you've been in one of those, not any less dangerous than a tornado, but very, very different. Okay, and we can go on. So that's, again, the tornado that I saw. And if you ever see a funnel cloud like that, do not stay outdoors. Get indoors as quickly as possible. Get to an inner room, even if it's just a funnel cloud, or if you start seeing fast rotation in the cloud. Slow rotation, not a big deal, but fast rotation. Get yourself indoors. Get into a safe place. Okay? I took this picture because I knew the storm had already passed. Otherwise, I wouldn't be out there taking that picture. And I've got pictures, videos of other storms where you can actually hear me talking, and I said, this is getting too dangerous, and I go in. Okay? So in this case, I made everybody stay in the house inside in the inner rooms and said, I will let you know when it's safe to go. And I know how fast these storms were moving, so I timed it and went out about 5 minutes afterwards and then took this picture. Okay? And I sent that also to the National Weather Service. So any other questions? One more slide, I think. Let's go to that. Let's see. Oh, yes. I take wonderful pictures of this area. And so one of the things I do on my Twitter feed is when I take pictures, I put them up on the Twitter feed. So if you guys want to see some really cool pictures of the sunsets and the sunrises and these lenticular clouds and the Kelvin-Helmholtz instabilities and tornadoes or whatever, follow me on Twitter. You'll be surprised. I don't do it very often, but I do when I do put things up, they're very spectacular. So this was actually taken at my home here in Las Cruces. And no filtering. I don't use filters. I don't use, I just use my camera phone as is. So this is actually the way the camera phone would take the picture. So If you talk to the photographers, they're probably pretty fascinated by the fact that I can get a picture this good without any filtering or any change in speed on my camera. I just know when to take and where to take the pictures is what I do. So that's it for my presentation, folks. Let me tell you my email address at the university. It is M, as in Michael, and then the first 7 letters of my last name, which is DeAnton. So M, DeAnton, at New Mexico State University, which is nmsu.edu. So MDEANTON at nmsu.edu. You can look me up. I'm on the physics department website for the university, so you can go physics.nmsu.edu. You'll find my email address there and my office phone. I will tell you, because of COVID, I'm not in my office. You can leave a message there, but I might not get it for a year. Okay, so send me email instead. So if you have any further questions or comments, or you want to find out how to get more involved, we did an urban heat study here. We've done Kokoros here for many years. There's all kinds of other citizen science projects we can get you into. And in fact, Dave is often looking for volunteers for the New Mexico Climate Center to help him with things like his weather instruments and so on. And that's it, folks. I'll take any further questions, and then we'll call it a day. Fine. So we'll go ahead and end the session here, folks. It was nice talking to you. I hope I get to talk to you again next year. We're actually going to do a southern component of the science fair, so there'll be things happening up north in Albuquerque like usual, but next year we're going to probably do a bunch of stuff here in the south, and I'm the coordinator for that. So if you're from Las Cruces or Alamogordo or someplace in the south, and you want to get involved with the science fair, this is your chance. Just contact me using that email, and we'll get you involved. Okay, and that's it. We can close it out here. Thank you, Caitlin. Really appreciate it.
Thank you very much.